Hi everyone, welcome back to our channel. Today we are going to learn about the steady state analysis of an inductor, which is also called sinusoidal supply applied to an pure inductor. Let's try to see here. So this is our AC supply is applied to an inductor. So the value of inductor is given by L henries. So the behavior of the inductor will be of two categories. So let's try to plot. So the applied voltage is V equal to Vm sine omega t. Automatically a current of I amperes will be flowing. Now I'm going to plot the graph of current versus time. Okay. So whenever you give the supply, AC sinusoidal supply to an inductor, basically it will try to charge. Okay, after getting charged it comes to an steady state. Okay, so now we are not discussing about the transient state where this time is called transient state and the state is called steady state. This transient state is available for a shorter time, which will be some 4 milliseconds, which is called 4 tau, and after 4 milliseconds is nothing but after 4 tau the inductor comes to steady state. The behavior of this inductor in this state is called steady state. The behavior of this inductor less than 4 times the time constant is called steady state. To understand this transient and steady state, let's try to see here. We have been opened the tap. So the tap is called voltage and the water flow is called as current, and slowly the mug is getting slowly filled up. So this is called the transient time. So whenever the water mug becomes full, I can say that it has reached steady state. So the portion of the mug is now in steady state. The portion of the mug is filling the water is called as transient state. So this transient state, the time taken to fill this mug will be just only 4 seconds or 4 milliseconds in practically. So that's how we are going to differentiate the steady state as well as the steady transient state. So now let's try to understand the equations. Okay, so the applied voltage is V equal to Vm sine omega t. So already we know that from the basics, the voltage across an inductor is given by small v equal to L di by dt. So what we are applying is V, so instantaneous quantity. So instantaneous quantity I can write it as V m sine omega t, that is equal to L di by dt. I require the value of current. So how to find the value of current is very simple. Okay. So now this current is in the form of differential. Let's try to bring this L to the denominator. Therefore, we are going to get Vm divided by L into sine omega t, that is equal to di by dt. I want the value of current. Therefore, apply integration on both the sides. When you apply the integration on the both sides, integral of di divided by dt is equal to integral of Vm divided by L into sine of omega t. Okay, so from here the differentiation integration will get cancelled out. Therefore, you are going to get current I is equal to 1 by is nothing but Vm divided by L into integral of sine omega t. Okay, multiplied with dt. Okay, so let's try to perform the integration and let's try to solve the answer. So here this I is equal to Vm. So integral of, from the basics we have the integral of sine theta. Okay, so integral of sine theta is equal to minus cos theta. So from here also I can write down integral of sine theta is equal to minus cos omega t, and we are performing with respect to dt. Therefore, we will get this in the denominator as omega. So now this is the magnitude we have been obtained. Therefore, current I we can write on it as minus Vm divided by omega L of cos of omega t. So this is in cos, by I require in sine. I can write on it as sine pi by 2 minus omega t. I can write down it as cos omega t. So why? Because sine 90 is how much? Cos omega t, and we are in first quadrant. In first quadrant, sine is there, automatically the answer is plus. So this cos omega t, from the basics of trigonometry, I can write down it as sine pi by 2 minus omega t. Therefore, I can write down I is equal to minus Vm divided by omega L, and this cos omega t I can write down it as a sine of pi by 2 minus omega t. So just multiply the minus inside the sinusoidal value. Therefore, I is equal to Vm divided by omega L into sine of omega t minus pi by 2. Okay, so now this is the formula. So here this is called as XL, which is called inductive reactance. Okay, so XL is called inductive reactance. L is nothing but inductance and X is nothing but reactance. Inductive reactance, generally we will put plus J. Later I will derive why we will be get plus JXL. So this JXL can be written as plus J omega L ohms. This omega L ohms I can write down it as L is equal to 2 pi F L ohms. Okay, so now here you can see here. So this is what we are going to get. So therefore current I is equal to V by R. I'm going to write down it as I maximum sine of omega t minus pi by 2. So this is the instantaneous quantity which varies with time. When you want to write down the RMS, IRMS is equal to IM, the maximum value obtained here, divided by root 2 into the angle made is how much? Minus 90 degrees. So this we can write on it as capital letter I at an angle of minus 90 degrees. Now let's try to check here why you are going to get the plus or minus here. Okay, so we are going to define the inductance. Okay, so we have the formula of R, which is nothing but XL. Okay, so why we are getting plus, we'll try to discuss. So XL is equal to V by R. What is the value of V? So V at an angle of 0 divided by I. Okay, what is the value of current in an inductor? I at an angle of minus 90. Okay, so therefore here we can write down it as V at an angle of how much you are going to get this as some 90 degrees. So therefore this V by I can call it as X L, and this J I can write down it as plus J. Therefore the inductor will be written as plus J X L ohms. Okay, this is what you have to understand for an inductor, how to write down the resistances with the polarity of plus J XL ohms. Okay, therefore the total impedance we can write down it as R plus J X L ohms. The units of XL is ohms, the units of R is also ohm, the units of Z is also ohm. Okay, so this is how to write down the impedance, which is nothing but in rectangular form. This is the format of writing in rectangular form. If you want to write down the impedance in polar form, you can write down the impedance in polar form as Z is equal to root of R square plus XL whole square, and theta is equal to tan inverse, tan theta, or you can write down theta equal to tan inverse imaginary part is XL divided by R. So these are very simple ways of writing the impedance offered by an inductor. Okay, so that's how we are going to find out. So this is what we are going to call it as inductive reactance, which is plus JXL plus J omega L, which is nothing but plus J 2 pi FL ohms. Okay, so that's how we are having the current as a minus 90 here, and how to write down the polarities like this. Okay, so this you have to remember. Okay, now let's try to define what is this inductive reactance. Okay, so inductive reactance is very important formula. The inductive reactance we are going to define as, so plus J X L ohms. So this is nothing but it is defined as, so here also this like an resistor. This is the opposition offered by the inductance. Opposition offered by the inductor or inductance. So opposition offered by the inductor to the flow of current through an sinusoidal supply. To the flow of current of an flow of current of an AC supply is called as inductive reactance. This, like you can see here, is like a resistance. This resistance is due to the property of inductance. That's why it is called the opposition offered by the inductor. Due to the opposition offered by the inductance or the inductor to the flow of current in an AC supply is called inductive reactance. Now let's try to draw the phasor diagrams. Okay, so phasor diagrams are very simple, so you can draw it. Okay, so coming to the phasor diagram. So there are two ways of representing the phasor diagram. Let's try to use the method 1. Okay. So method 1 we have already we discussed here. V equal to Vm sine omega t and I equal to Im sine omega t minus pi by 2. So V is equal to V maximum sine omega t, V maximum sine omega t, and I is equal to I maximum sine of, here you can see here, I maximum is equal to Im sine omega t minus pi by 2. Okay, so now let's try to draw the waveform. Okay, first draw an x-axis. This is nothing but the x-axis. So here we want to draw the voltage. Let's try to mark the voltage, and here you can see here from 0 it start increasing and has positive magnitude, comes to 0, and once again it goes negative and it has the negative magnitude, and it maintains an voltage of plus Vm. Here it maintains a voltage of minus Vm. So this is the waveform of voltage. Okay, so now here you can have an angle of minus pi by 2. So how to draw this waveform is, now let's try to segment into, so this is sine 0 one part, this is another part, this is another part, this is another part. Let's try to change the color where you can understand better. Okay, so here theta is minus 90. Okay, so then how to draw it is very important. Okay, so theta is 90 means it should touch with a negative axis. So here at negative axis it has to start. So it has to start at negative and it go through 90 and it should maintain its positive angle, and it should get closed here and it should continue its path like this. Okay, so at, so this we are going to draw at theta is equal to omega t. So how to understand this one is, at theta equal to 0 or at t equal to 0, the current I should have negative magnitude. Okay, so what is the meaning here is at t equal to 0. So here at t equal to 0, the magnitude of voltage, okay, sorry, the magnitude of current is how much? Negative. Whenever the magnitude is negative, automatically you'll get minus 90. Okay, so this is how our waveform is traveling with respect to voltage and current. So here we are going to make a comment. The first one is voltage, second one is current. Okay, and it maintains an angle of minus 90. Okay, so I can say that when you are this direction, here you are going to get a inductor. Okay, so here at already we discussed in phase, you are going to get resistor. At this side you are going to get capacitor. Okay, here I can make a comment. Current lags voltage by 90 degrees. So this is the first technique of drawing. Now let us try to see the second technique of drawing. So method 2 is nothing but we have the voltage, where this voltage we are going to write down it as Vm divided by root 2 at an angle of 0, and I we are going to have as Im divided by root 2 at an angle of minus 90. You can check out here. So how to write down the current? Already we had written I at an angle of minus 90. Okay, so here you are going to get minus 90. Now let's try to take this voltage as an reference. So voltage RMS quantity is nothing but Vm by root 2 at an angle of 0. Okay, so now current is lagging. When you are traveling in clockwise direction, then you are going to get negative. Okay, so what is the magnitude of the current? So this is I, and it makes an angle of minus 90 degrees. So minus 90 means it will be traveling in clockwise direction. So here what is first and what is second? Voltage is first. What is second? Current. Therefore I can say that current lags voltage leads by 90 degrees. This is how to draw the phasor diagram. So these are called the method of drawing an phasor diagram by method 1 as well as by method 2. So here we are focused. So this Vm by 2 is nothing but we call it as a VRMS. This Im by root 2 we are going to call it as IRMS. Okay, so this is how we are going to use the two methods, and we are going to draw these waveforms of, and how we are going to conclude current lags the voltage with an angle. Okay, so this is all about the inductor. Now let's try to see the characteristics of an inductor. Okay, so whenever you plot the characteristics of a frequency, so how to write down the inductance? We can write down it as plus J X L ohms. So we can write down X L ohms. XL is equal to omega L ohms. How to write down the omega L? We can write down it as a 2 pi F L ohms. So now I'm going to draw the diagram of frequency versus XL. You can see here XL is directly proportional to frequency. With the increment of frequency, XL value also is going to increase. Now let us try to draw the graph. Okay, on the x-axis I am taking frequency, and the y-axis I am going to take inductive reactance. Okay, so this is nothing but in ohms. This is in terms of hedges. Here you can see here, if frequency is 1 hedge, frequency is 1 hedge, and the resistance offered is also 1 ohm. If the frequency is 2 hedges, and the reactance offered here is also 2 ohms. If the frequency is here, the frequency is 3 hedge, and the resistance offered is also 3 ohm. So when you join these common points, you can see here this is an straight line flowing through the origin and maintains a slope of m is equal to 1. Whenever the slope m is equal to 1, we can say here the relationship between XL and frequency is a linear relation. They follow a straight line relation or a linear relation. Okay. So now one more doubt also is there. What happens to an inductor when a steady state is applied? Okay. So the formula for current I is equal to V by XL. How to write down XL is omega L. So we can write down it as omega L as a 2 pi F L. Okay. So whenever the DC supply, what we are applying is AC supply. Now let's try to apply the DC supply. When you apply the DC supply, V by the DC supply, there is no frequency. So whenever the frequency is 0, the current becomes infinity. Okay. So whenever a DC supply is given to an inductor, so I'm giving an DC voltage, automatically this current becomes infinity and sending the maximum current, automatically the inductor gets charged. Okay, inductor gets charged. Okay, this is in the case of an steady state. It acts as a short circuit and it stores the energy. So I already told what is the transient state and steady state. Okay, so now just the switch is closed. This is I of t, and this is nothing but t. So suddenly just we are closing the switch, the inductor slowly charges and it reaches. Okay, so this period we are going to call it as a transient state, and this state you are going to call it as steady state. So what happens to the inductor is it is getting charged. Okay, slowly it is getting charged, and here it is acting like an short circuit in the steady state, and it gets stored. The inductor gets fully charged. But in the case of transient state, what happens is so if you keep an switch, you can understand better here. So here we are going to have a switch. So whenever you have an switch, this is t equal to 0 minus, this is t equal to 0 plus. So as soon as you give the supply, what happens is, so slowly the inductor will get charged. Okay. So as soon as you give the supply, it will not allow the sudden change in current. That's why first initially it will act as an open circuit, and from open circuit it will be there in steady state, and later it comes to steady state, making the inductor as an short circuit, and inductor gets fully charged. Okay, so as soon as you close the switch, the inductor initially it will not allow the sudden change in current. Why? Because the current switch has been changed. So initially this inductor will try to act like an open circuit, and after a t equal to, for example, let's try to take this transient time is for lesser time. Let's take this is operated only for 4 milliseconds. After 4 milliseconds, the inductor comes to steady state. Okay, therefore inductor will try to act like a short circuit and stores the energy. This is what the behavior of an inductor in the case of a DC supply. But in the case of AC supply, it is directly offering the inductive reactance in terms of ohms. So same behavior also in the AC supply also, it will try to charge and it comes to final state. So here the inductor gets 100% charge, and here it is 80 percentage or 90 percentage. This the period of getting instantaneously charging is called as a transient time or transient state. This period is called steady state. That's how to understand the behavior of an inductor under transient state of mode as well as steady state of mode. So very simple. Inductor gets current. Here the current becomes infinity. The inductor gets short circuit and gets charged in the case of an steady state. So this is how we are going to understand what happens to an inductor in steady state. Okay, so this is the behavior of an inductor under steady state. Inductor gets fully charged. Okay, this is what I already explained in the state. The inductor gets fully charged. Okay, this is what we call the steady state behavior. Only steady state we are studying. Okay, this is called the steady state behavior of an inductor. If you feel my explanation is good, please like to my video and share this video with your friends. And those who have any doubt what about DC supply, AC supply, what happens, everything is clearly mentioned. Still, if you have any doubt, let me know in comment section. And if you're watching my channel for the first time, subscribe to my channel with the name kvthulasi. Okay, so hope you are able to understand. We'll meet in another beautiful video.